All right, hello everyone. So today we're looking at a discrete math problem. We have solve 4x is congruent to 5 mod 71. So we have a linear congruence problem. And in general, ax is congruent to b mod n. We'll have a solution if the GCD between a and n is equal to a number m, and m divides b. All right, so we have to first of all check that out, see if that's the case or not. So we're going to take the GCD of A, which is 4, and N, which is 71. And, right, what's the greatest common divisor between those two is 1, right? 1 is the biggest number that divides. The next thing we're going to do is we're going to check that 1 divides 5. And, yeah, 1 does divide 5. So we're good. So we can go through this. There will be a solution here for us. Now, how do I actually go about getting a solution? This method involves mainly solving an equation, which is what you see here in step 1, which says find a solution to this equation, and that solution is this a with the little bar over it, a bar, let's call it that for a second. And a bar satisfies this equation, a times a bar equals 1 mod n. So in our case, the a was 4, and n is 71. Okay, so we're looking for the solution of this equation. 4 times a bar is congruent to 1 mod 71. Sorry, if I said equation, I meant to say congruence here. Apologize. So what are we looking for? We're basically looking for a number, a bar, such that 4a minus 1 is divisible by 71, or that 71 times some number r gives you that. Okay, so 71 times the number r equals 4a bar minus 71. So what could that number be? Well, we often do these problems by inspection. Okay, and let me erase this real quick. And the way to look at it is ask yourself, what number times 4, whatever that result is, minus 1 divides 71. That's another way of saying what we have here. Well, in this case, if you look at a number near 71, like 72, 72 is divisible by 4. So 4 times 18 would be congruent to 1 mod 71. Okay, so the idea here is, can we find a number that is maybe close to, in this case, 71, which is 72 that like 4 divides into. And yeah, 72 works. And 72 would be congruent to 1 mod 71. And yeah, if you subtract 1 from 72, that's 71, and 71 does divide into 71. So that's what we're working with here. Now, the other method, if you don't like this guess and check method in a way, you can go ahead and try to use the Euclidean algorithm to find that. And I have a separate video on that, and I'll link it here for everyone. But for in the meantime, the solution for this a bar would be 18. And your next step here is to take your a bar and multiply both sides of your original equation, ax is congruent to b mod n, by a bar. And the solution here is what you see written down here. X is congruent to a bar b mod n. And there's an infinite number of solutions. So in our case, it would be 4x times 18 is congruent to b, which was 5, times 18 mod 71. Okay, that is your solution. And unfortunately, because of time constraints, we don't really have time to go over why that is, but this would be your solution. And x would equal 90 mod 71. Now, 9 mod 71 is equal to saying 19 mod 71, right? Because 90 goes into 71 19 times, so they're equivalent. So we have our solution to be x is congruent to 19 mod 71. Any integer that is congruent to 19 mod 71 is an answer. So you have an infinite number of answers. However, we have that uniqueness up to 19 mod 71 that we have, okay? So that is how you solve a congruence of this type here, of linear congruence, and I hope this helped. Thank you for your time.